All right, so welcome to IASG. So today our presentation is on IoT hacking, or hacking Internet of Things devices. So first of all, though, we're going to get started. Oh, actually, anybody know what 0x65 is in decimal? Any guesses? 101, yep, IoT hacking 101. So the weekly puzzler this week. Has anyone got anywhere on last week's puzzler at all? Nobody? All right, so the new puzzler here is available on our GitHub. Apparently more file format abuse. And the flag is in the standard format, IASG. Words and underscores in the brackets. Make sure to check that out. All right, so last week, Jeff, is this a solution to last week's, or is it a hint?
Looks like this solution.
So our puzzle guy is not here today, so I don't really know how to give you this, but this will be in the slides afterward, and you can take a look at the solutions if that's what this is. Before we get started, in the news today, or this week, Jeff, you want to do the news?
No, I'll let you do it.
All right, so first of all, I think it was in Austria, hackers held an entire hotel for ransom. It had locks that were internet connected in the rooms, and they could use those locks to lock all the doors and force all the guests to pay about $1,600 in order to unlock their room door to get out. So that was a bit interesting. And also, Jeff found a cool heat map of cybersecurity demand for jobs, supply and demand. So afterward, you can click on that link and see the website that he has there. All right, so let's get started. So what is the Internet of Things, or IoT? Well, Wikipedia has a long description here of anything that you can imagine, like buildings, vehicles, anything that's connected or smart. But I would just make it shorter and say anything that's on the internet that really shouldn't be. So, and we'll see why today, why that is. Yes, definitely. So what kind of devices? Anyone have any ideas of what kind of devices we'll see that are Internet of Things? Anyone have any ideas? Yeah.
Security cameras.
Security cameras, big one, yeah.
Wall outlets.
Wall outlets, yes. Matt?
Toasters.
Toasters. Victor?
Snipers.
Sniper rifles, yes.
Refrigerators.
Refrigerators, and yes.
Decals.
All right, and we'll actually see a couple here. Like here's a toaster, it prints your weather every day. It connects to the internet, gets the weather forecast, prints out the weather on the toast. Who wouldn't want that? If my slide changer would, okay, smart refrigerator. You can see what's inside the fridge on some cameras that are all internet connected. It can make shopping lists for you, and it's running Samsung's clone of Android called Tizen, or Tizen, however you say that. Android Auto, smart cars. This is very up and coming and very new still. Lots of security issues here. And you might have seen Google Home and Alexa are both products for your home that can automate lots of things, and they're always listening to your voice too, which is great. We like being recorded. And one of my favorites, the egg minder, the smart egg tray. I actually have one of these. Costs $10. It tells you when your eggs are bad. It doesn't work at all. But it was kind of fun to play with and see if I could do anything with it. Fun. And also a pan that talks to the internet. I have no idea what this does, but it's a thing. And lastly, pretty much everything else you can imagine. So routers, webcams, an internet-connected belt, pacemakers, inhalers, Brita filters, forks, you name it, it's on the internet, which is pretty disturbing nowadays, but it's reality. So common design principles, I'd say: insecure by default, usually bad design decisions, usually done in a rush. They want to push the product out without really refining it and securing it. A lot of times the code is based around lots of hacks and it's full of bugs. Usually they're not patched after they're released, meaning lots of vulnerabilities and lots of fun to play with. And I just had some quotes here from news headlines that make it sound like it's a pretty bad thing. IoT is turning into the Internet of Thugs, and every device has an average of 25 vulnerabilities. I'm sorry you can't read the left side of the screen here, but so notable events with IoT devices in September this year. You can see these are all really recent, since IoT is pretty new for the most part. So in this September last year, the MyRay botnet, I'm not sure how to say that, but almost 50,000 devices were compromised, mostly IP cameras. And this botnet of IoT devices was used to take down some major websites. Notably, KrebsOnSecurity.com was taken down by this attack. And what's kind of funny is when it gets on a device, it'll try to remove other malware and secure the device from future attacks, which is kind of amusing. And the source code was recently released for this as well, so if you want to see how it works and how it was used in these attacks, you can find that on the internet. And in November of this year, there was a worm developed a proof of concept for the Philips Hue smart light bulb. And this could spread from bulb to bulb without any internet backbone between them. Using the Zigbee protocol that's what it uses. And some researchers did some experiments and concluded that it'd be possible to spread across Paris. And they could launch the attack from a quadcopter that had some wireless equipment on it. And once these bulbs are compromised, they could try to jam other Wi-Fi networks and do other bad things like that. So I found this cool picture here of the dangers of IoT. Down here at the bottom, you can see not very dangerous smart light bulbs and smart fridges, but at the top, we get security systems and other infrastructure devices. And what's cool about a lot of these things is they're running pretty complicated operating systems most of the time. So you might have a camera that's running a small version of Linux. Even though it's kind of going to be a stripped down version, it's still Linux. It still has lots of utilities on it. And it can still be dangerous if someone compromises it. Whereas down here, smart light bulbs, I actually brought one today and we'll be looking at that in a second, but a lot of those are running some kind of small real-time operating system that is more limited but still offers some opportunities to play with. So today we're going to talk about attacking an IoT device, this bulb in particular. It's a smart bulb from a Chinese company. I think it's called Magic Home. It goes for about $12 on Amazon, I think. And I have a couple of these in my house, and they're actually quite nice to use for home automation. I have an app I'm developing for that, but you can talk to them from the mobile app on your phone. Let's see if this is working. So this nice app here that lets you control all your bulbs in your network. I don't know if you can see this bulb here, but I'll change the color a bit. Make it blue, red, green. It does everything. Has some fun flashing modes on there too. But we're going to look at how we can take over this bulb and do some fun stuff with it without using the app. All right. So first of all, yep, there's the bulb. That's what it looks like when it's not in the lamp. So first of all, what I did when I was playing with this bulb over the summer, I wanted to see how it worked, how it talked on the network. So I started doing this by taking out my trusty man-in-the-middle tools. And there are some past presentations that I have done. You can look at those if you want more details about how to do man-in-the-middle attacks. And I'm sure we'll cover them again at some other time in the semester. But that's what I did to figure out how this bulb works. So I'll just quickly show what I did there. So we're going to man-in-the-middle this device so that all the traffic that my phone sends to it will be going through my computer first. That should be working. So I have the app open, and I'm going to open Wireshark, which is a network sniffer and packet analyzer. It's a lot of fun to play with. All right, so actually, we're going to see what the IP address is of that bulb first, just to make my life easier here. The bulb is 1.2, okay. So right now, once I try to connect to this bulb through my phone, we'll start to see the packets here in Wireshark. I'm going to filter it out so we only see that bulb, since there's lots of other stuff happening at the same time. All right, so I'm going to reopen that app real fast here. And we can start to see a bunch of stuff happening here. Of notable interest, I'll zoom in. There's a UDP message right here that's sent out from my computer to the bulb at 1.2 on port 48899. Down here in the message, we can see a message. HF811 is related to the Wi-Fi chipset. And this is actually, I found out later that this is actually like the authentication of sorts that the app does with the bulb. It's not really authentication at all, but that's what it does to say, hello, I'm an app, I want to control the bulb. And then all this other stuff happens here. And once I start controlling it, changing the color, as you can see, the bulb is changing color up here. We see more messages happening on screen. And if I were to look at one of those, I eventually figured out that down here where it's in blue, this is the data part of the message, so that's the only part that we really care about. You can see here when we change the color, these 3 values change. So that's actually the hex for red, that's the hex for green, that's the hex for blue. And this is like a mode, and there's some other stuff like the white color of the bulb as well, and a checksum at the end here. And I figured this out after looking at the packets for quite a while and seeing when I changed the color in the app what happened here in Wireshark. So if I set it to, well, right there you can see the color. The color is full blue right now and plus some red, so you should see blue at 255 or FF in hex, which is right here. So that's our blue value. If I were to make it like all red as much as possible, that's pretty close. We'll see here, oops, down here at the bottom, there's the red right there, green and blue. So it's mostly red. And so given this, what can you do with this information? Well, in my case, I use this to write my own Python script that could control these bulbs and do more fun things with them than just using an app, since that's kind of limiting if you want to do automation and stuff like that. So I wrote a pretty simple script that will take in values and send to the bulb, and this can be integrated in some other application. It's available on GitHub under my gists if you want to look at that after the presentation once the slides are released. And actually, I have a demo of that too, that's right. So this is part of my app, but it talks to a server over WebSockets and can talk to the bulb. I have to change something real fast, though. So now when I move over this, the bulb is changing color. I don't know if you can see that. That's over WebSockets. And that's an example of what you could do with reverse engineering a bulb like that with the scripts like that. So back to the slides. OK, so that's interesting. We figured out how the bulb worked and can control it with our own means now. So what else is there to this bulb? So pulling out the handy Nmap network scanner to see what services are running on there. Oh, man, you can't see a thing on this. That's a little bit better there. OK, so we scan it with Nmap, and we see there are 2 services. Now, I didn't mention that the 5577 was the port we were talking on earlier with the colors of the bulb. And we know what that does already. It's pretty uninteresting. But what's here on port 80? Well, usually that's where a web server is running. And in this case, Nmap has identified the server as a limitless smart lightbulb bridge HTTPD server. And so I looked around quite a bit for what this is and what I could do with it, if there's any vulnerabilities in it. I didn't really find too much, but I was curious what happens if you go in your web browser and open up this bulb, type in its IP address, what do you get? Well, so you get a access denied page. It's asking for a password, username and password. I spent hours, or my computer spent hours trying to brute force this, trying to guess what the password is. And it was not successful after many hours of trying, although I eventually found on the internet while searching that the password was in fact NIMDA. Anyone know what NIMDA is? It's admin backwards. It took me too long to figure that out. But I was surprised that none of my password lists had admin backwards in them, so that wasn't helpful. But I found on this guy's GitHub page, he had already done a bunch of stuff with this bulb and had talked about all of its functionality and the web interface as well, and he gave away the password. Although one thing they did when they released this bulb is they changed the password from admin to admin NIMDA. So they did something at least, they tried. So I tried that, and I got past the authorization. I expected to see this nice web interface that the wireless module is supposed to provide for configuring the wireless functionality. But apparently, my bulb doesn't have that, so I was forced to see this instead. And not what I wanted, obviously. I wanted a nice, flashy web interface that had all of the settings on it, but we just stuck with this. I tried to brute force all the directories on this thing, didn't find anything. Finally, I found the manual for the wireless module on the internet, and it gave me lots of information about not only the web interface, but also some debug modes, which we'll look at too. But it gave me one HTML page, iweb.html, where there's an upgrade firmware functionality. So that seems interesting, right? And I should mention that this is all part of the HF LPB, which is the Wi-Fi part of the bulb. It's not like it's the majority of the bulb software is this Wi-Fi running on this Wi-Fi module, but there's a firmware upgrade page, which is very interesting. So sure enough, in my browser, I could get to that page. Unfortunately, this was last night that I figured all this out, most of this out at least. So I didn't have time to mess with uploading my own firmware. But I downloaded the firmware from the website. It's available to anybody, and I'm going to plan on looking at it and seeing what I can do with it later on. But this could be bad if someone was on your network, they find a bulb, and they can put their own firmware on there that can run more advanced commands and keep attacking other devices in the network. So besides that, the manual was super helpful in pointing out other debug modes for controlling the Wi-Fi module. So this bulb is pretty similar to a lot of other devices you buy that are Wi-Fi connected. So when you first turn it on, it has its own Wi-Fi network, similar to like how a Chromecast works when you set it up the first time. It has its own Wi-Fi network. You connect your phone to that network, and then it configures it to talk to some other network. And so that's what this module kind of does, all that. And this port that's open allows for a lot of that configuration. And you saw at the beginning there, that's what the app used that port to scan for the bulbs actually. But it turns out it has a lot more options than just finding bulbs. And I was able to derive a script that could talk to this app as well. A simple Python script. Another thing on GitHub that you can look at if you want, but it's really not too complicated. It just opens a socket and sends a message in the format they expect after sending their authentication code, which is not really authentication at all. The scary part is supposedly these bulbs are on the internet and you can connect to them over the internet. And this port allows for functionality such as, here's the entire list of commands it accepts over this port. And one of the most worrying ones is that it can dump the Wi-Fi password. So let's say you find this bulb on the internet. Well, now you have someone's Wi-Fi password. So my password here was "this is stupid" is my Wi-Fi password. So you can see that there. I was able to reveal that. And this would be bad. I mean, if you're already on the network, it doesn't matter too much because you probably know the password. But if you find these bulbs on someone else's network, you could easily talk to it and find their Wi-Fi password, giving you access to that network. Another one that was kind of concerning is proxying through the bulb. So one of the functions, if I can go back to that, maybe you can't see it on this list, but one of the functions the bulb has is, or the Wi-Fi module has, is to send an arbitrary HTTP request. So you could tell the bulb to fetch google.com if you wanted to. It has just some debug or test functionality, I think. I'm not really sure why it's there, but you could use this to proxy your traffic through someone's smart bulb in order to make it look like you're coming from that IP address or something like that. Or use the bulb as to hide your traffic like that. I tried to do this, but in my limited testing in the past day, I wasn't able to actually do it since it would throw a connect error right away. That's their attempt at saying connect, I think. And it sent a TCP SYN. The SYN ACK came back from my server, and then it just reset the connection and nothing happened. So I don't know why it didn't work. I was hoping it would work, and I wanted to make a script that could proxy my traffic through it. But I was not able to figure that out in the limited time I had. It didn't seem to work. And also, the app has a remote mode. So if you're away from home and you want to control your smart bulb, well, luckily the app can do that for you. So you can create an account on their website, and the bulb talks to the server, and your phone talks to the server. So wherever you are in the world, you can talk to their publicly available server, and it'll talk to your bulb for you. The thing about this is that's all over HTTP, and it's not HTTPS, so it's not encrypted. And if someone happened to see that, they could take over your bulb as well. Not really a big deal. I mean, who cares if your neighbor is controlling your light bulbs? I don't know. Could be an issue, but probably not. Just another consideration they didn't really think about is that anyone else could look at this traffic and do that with it. You can see this device ID, and here's all the commands that change the colors and stuff encoded in there. So my next steps with this bulb, I might try to reverse the firmware and see what's in there, see if I could make my own firmware that I could install on a bulb and then actually cause some damage with it. Maybe you could install some other utilities on the bulb so I could do more invasive things to someone's network if I got on their bulb. Other things like that, perhaps. And figuring out how to proxy through it. As I mentioned, that feature seemed broken, and it'd be kind of cool to get that working. And also some resources for this particular bulb and similar ones. There's a Git repo. I have a couple of scripts that I showed you earlier. There's some articles, and the website also has all the manuals and the firmware that you can play with to your heart's content, which is great. And we've had some previous talks in the past on finding these devices and similar devices on the internet. There was one that Jeff did a while ago, a search engine for the Internet of Things, which talked about Shodan and Census.io, both of which are search engines for devices instead of web pages. And I also had a presentation a while ago on Google Dorks, which is using Google's special search terms to find certain things on the internet. So you could use both of these techniques to perhaps find bulbs like this or many other things, mostly cameras, but sometimes there are surprising things on there like, SCADA systems, or I found some weird security systems and like traffic light cameras and license plate readers, stuff like that you don't expect to find. It's pretty easy to find if you know what you're looking for. That being said, if you find something on the internet that's cool, don't mess with it. It could be very illegal, very, very illegal. And if it seems like it shouldn't be on the internet, which is a lot of things, probably should be reported to the appropriate authorities. Any questions on anything we talked about? Yep.
In general, how do you get authorities to care when you found them?
What was that?
How do you get authorities to care when you found them?
Well, let's say it was something like like the Hoover Dam was on the internet. That'd be kind of concerning, and they might see that. If you told them that the Hoover Dam is on the internet, I think that's an immediate concern for anyone in the area, I guess, or any other infrastructure like that. You wouldn't want to have that on the internet. And I feel like someone would understand that the grave necessity for that. I guess, are you saying that they might be like, oh, what's the big deal about?
Well, not IoT, but wise. But I mean, I've taken concerns to people before, and it seems obvious to me that it would be a big concern, but people just like, oh. And
Well, okay, some things are weighed against risk and to the company as a whole, and a lot of times it doesn't really matter enough that they care about it. Obviously, in cases like a bulb being on the internet, not really a big deal. But a SCADA control system for a nuclear power plant, you don't want that to be on the internet. So it depends on the risk of what you're talking about, I guess. Any other questions on anything related to this at all? Yes?
What was the name of that bulb again?
For them, Amazon.
I can post the exact links to the Amazon product because it's some very generic LED bulb name. Yeah, I'm not sure what it's called exactly, but I'll try to post that in Slack later on. Yes?
If you do happen to find a vulnerability, is it illegal to post your research on the internet?
There are certainly practices for responsible disclosure with vulnerabilities, but there's nothing stopping you from just posting it, although the company might get mad at you or something for doing that. But usually you let them know and give them some time, and if they don't respond, then it's usually okay to release it, considered okay to release it at that point. And bug bounties as well. Lots of companies want you to do this, and then they'll take your vulnerabilities and maybe pay you money or something else. So, any other questions? No? Going. Okay, so the slides are available for this presentation and many past presentations at that link. That link's also posted in Slack quite often, so it's hard to miss. And if you're not on Slack yet, you can join us on our Slack at iasg.slack.com. It's a chat service that we all use to share cool things and talk about the club and random things as well. But I suggest you join that with an Iowa State email address if you're interested in joining. A few of us are on there all the time, and we're always open to discussions, so thank you.